Question 1. Label the opposite side, adjacent side and hypotenuse in the triangle shown. Here's our reference angle theta. This side here is adjacent to the angle. This side here is opposite the angle. And this side here is the longest side in a right angle triangle, and it's the hypotenuse. Question B. Determine the exact value for sine theta, which is opposite over hypotenuse as a ratio. Our opposite is 6 and our hypotenuse is 10. So that would be a ratio of 6 over 10, and simplifying that would be 3 over 5. C. The exact value for tan theta. Tan theta, the identity is opposite over adjacent. The opposite here is 6, the adjacent is 8. So by substitution, 6 over 8, and simplifying that is 3 over 4. Question 2. Given tan theta equals 15 over 8, determine the value of x. Note our reference angle here first, which is theta. Label our sides. This side here is our opposite, and adjacent to it is x. So at the moment, we have tan theta being opposite over adjacent. In this case, our opposite is 45 and our adjacent is x. Now, given that our ratio here states that tan theta has to be in the ratio of 15 over 8, we can write 15 over 8 must equal 45 over x. Now to solve this, we can cross multiply or work out what sort of scale factor the triangle has been increased by. If we were to rearrange, x comes over to the left-hand side to become a multiplier, so 15x, and 8 goes to the right-hand side, and we have 45 multiplied by 8. So 15x equals 45 times 8, which equals 360. Divide both sides by 15, and x equals 24. Question 3. Determine the exact value of cos 36.5 using the diagram. 36.5 is our angle here. Our adjacent side here is 5, and our hypotenuse is 6.22. So according to this triangle, cos theta is our rule, our identity is adjacent over hypotenuse. Using the reference over here of the triangle, our adjacent side is 5 and our hypotenuse is 6.22. So in this case, cos 36.5, the exact value is 5 over 6.22. And if you didn't want decimals as part of your denominator, you can multiply both the top and bottom by 100 and write it as 500 over 622, which can be further simplified by halving both numbers. That's 250 on 311. Question 4. Calculate the value of each variable correct to 2 decimal places. Here we're working out the unknown value x. What we have to use is our reference angle, which is 52.5. We want to work out this side here, which is adjacent to it, and over here we have opposite side. So opposite and adjacent, we'll use tan theta equals opposite over adjacent. Substitute our values in. Tan 52.5 degrees equals 4.3 over x. Now to solve this one, we can multiply both sides by x. So x lots of tan 52.5 degrees equals 4.3. Now to isolate x, we'll divide both sides by tan 52.5. So 4.3 over tan 52.5 degrees. And we'll evaluate that on our calculator. X equals, which to 2 decimal places is 3.30 units. And next question, we have an angle here of 53.5 degrees. This is adjacent This is hypotenuse. Adjacent hypotenuse, we'll recall the rule cos theta equals adjacent over hypotenuse. Substituting our values in for theta is 53.5 degrees, adjacent is 3.7, and our hypotenuse is x. Similar to the approach in the first question, we'll multiply both sides by x, which leaves us at 3.7 on the right hand side. Now if we divide both sides by cos 53.5, cos 53.5, and x equals 6.22 units. A steel pole is leaning against the wall and makes an angle of 50.3 degrees with the ground. Calculate the distance x the base of the pole is from the wall. Our angle here is 50.3. Here is our hypotenuse in a right angle triangle. This is adjacent. Calculate the distance x from the base of the pole. So we want to work out x. We have an adjacent and hypotenuse, which is cos theta equals adjacent over hypotenuse. Cos 50.3 degrees equals my adjacent, which is x, over my hypotenuse, which is 6.89. This is an easier one because now we can multiply both sides by 6.89. And we can evaluate using a calculator what x is, and it is 4.40 meters. We have units in this question now, so you need to include units. Determine the length of the line segments IK and JK, given they are equal. We also note that in this question that IU and UJ, so IU is also equal to UJ. That means that's the midpoint of the line segment between I and J. Now IK is this line here, and it's equal to JK. What we have then is an isosceles triangle. Now because these two sides are equal, being that U is the midpoint, and this side is shared, we actually have similar triangles. So triangle 1, or IUK, is similar to triangle JUK. So triangle 1, triangle 2 are similar triangles. Now first of all, this angle in here, which is, we'll call theta. Theta, in this case, is half of 86.3 degrees, which is 43.15 degrees. That's a starting point. Now we can use this triangle to work out the length of JK. And inside this triangle we have an angle which we've now worked out, and next to that angle the adjacent side. And we want to work out this side over here, which is called the hypotenuse. So we'll use cos theta. So cos theta equals adjacent over hypotenuse. Cos 43.5 equals my adjacent, which is 3.2, over an unknown value, which is the hypotenuse, and you can call that JK or KJ. To solve this, to work out JK, we can write 3.2 over cos 43.15 degrees. Using a calculator now, the length of JK equals 4.39. And that also equals, therefore, IK also equals 4.39 because they're equal. Turn the value of the pronumeral correct to one decimal place. Here's the angle, the unknown. This side over here is the opposite, and this side here is the hypotenuse. And O and a H refers to the trig identity sine theta equals opposite over hypotenuse. The next step is to sub the values in. Sine x equals our opposite, which is 3 over 4.61. And to work out x, we're doing your inverse sine. So sine is the -1 of 3 over 4.61. On a calculator, we can answer that in 2 decimal places as being, so 1 decimal place as being 40.6 degrees. Which of the following equations would be used to determine the value of x? Here's x. This side here is a hypotenuse. This side here is opposite. So that means I'm looking for something that has O and H, which is sine theta. So we're going to rule this one out. It's either this, this, or this. Now if I wrote this out, we would have sine x equals opposite over hypotenuse. In that case, the answer is B. Sine x equals 5 over 6.4. New driveway measuring 7.59 metres in length has been constructed. The builders assured the new homeowners that the incline was less than 20 degrees. Determine if this is correct using suitable calculations. So here is our angle. This side here is adjacent. This side here is hypotenuse. So recall the rule, cos theta equals adjacent over hypotenuse. Now subbing our values. Cos x equals 7.2 over 7.59. Now to determine x, inverse cos 7.2 divided by 7.59. On a calculator, that is 18.45 degrees. Therefore, what we can say, in this case, 18.45 degrees is less than 20 degrees. Therefore, the builder is correct. They built something that was an incline of less than 20 degrees. Question 11. A bushwalker leaves camp and travels 4.47 kilometres. This is 4.47 kilometres. The bearing of north 63.43 degrees west. Calculate how far west of the campsite they travelled. So west here would be this length here. How far west from their original point are they? So that's our x. Now at this point, I'll rub this 4.47 out to make it easy to see. 4.47 is this length. We have an angle, we have a hypotenuse, and we have this side over here is opposite. So using sine theta equals opposite over hypotenuse, sine 63.43 degrees equals our opposite, equals x over 4.47. So x equals 4.47 multiplied by sine 63.43. X equals, to 2 decimal places, 4.00 kilometres. So what they've done is they've travelled 4 kilometres due west. A cyclist travelling 22 kilometres due south. On this diagram, we have north, south, east, west. We'll call point A the starting point and travels due south 22 kilometres. Then 16 kilometres due east from point B to point C. Calculate the true bearing the cyclist must follow to return to the starting point, the starting position. So if we have this angle in here, that will be helpful. We'll call that theta. That means on this side, we have our opposite, and this is our adjacent side. Recall the rule, tan theta equals opposite over adjacent. Tan theta equals 22, which is our opposite, divided by 16, the adjacent. Now to solve for theta, the inverse tan of 22 over 16, and our answer is, that is theta equals 53.9 3.97 degrees. Now to help us out work out this true bearing, we can draw a set of north, south, east, west axes. So there's north, south, east, west. We want to work out our true bearing. At the moment, this direction is our west. Now our angle here, theta, which is 53.97 degrees, is in this region. So to work out our true bearing, the direction is to travel back to our starting point. Now west is 270 degrees. We're going to add another 53.97 degrees. And our true bearing is 323.97 degrees true north. Question 13. A teenager spots a friend from an apartment building 60 meters above ground level. So there's our 60 meters, and this here is the teenager T. Given the angle of depression from the teenager to the friend is 40 degrees, so 40 degrees from the horizontal is our angle of depression. Determine the line of sight distance between both people. So what we're working out is the distance between T and F. Now, using our alternate angle property, this angle in here is also 40 degrees if we're assuming this and this is parallel. Now to work out the line of sight distance, we need to use one of the trig ratios. Using this angle here at 40 degrees, our line of sight distance would be the hypotenuse, and this side over here would be the opposite. So we need to recall the rule, sine theta equals opposite over hypotenuse. Sub in 60 for opposite, and our hypotenuse we don't know. Our angle is 40 degrees. And to solve this, our hypotenuse, or TF, if we'd like to call it, is 60 over sine 40 degrees. And evaluating that, our hypotenuse is 93.34 meters. Therefore, TF equals 93.34 meters. In our last question, question 14, the angle of elevation from point A to the top of a 100 meter tall tower is 30 degrees. The angle of elevation from point B is 50 degrees. So let's put those two angles in first. So point A, point B. And here we have our 30 degree angle. The next one is 50 degrees. Calculate the distance between points A and B. So we want to work out the distance between A and B. Now start with triangle 1. Triangle 1 can be our largest triangle. So here. Now to work out the overall length of that triangle, so we'll call this C, to work out the distance between A and C, we can use our opposite side, and this will be called our adjacent side. So part 1, tan theta equals opposite over adjacent, tan 30 equals 100 over, and we're going to call this length, which is highlighted now in green, this overall length, AC, between my points A and C. So therefore, AC actually equals 100 over tan 30. So that's part 1. Part 2, the smaller triangle. The smaller triangle here contains an angle of 50 degrees, and its side, its adjacent side, is called BC. So using that triangle, we could write tan 50 equals 100 over BC. So BC actually equals 100 over tan 50. That's equation 2. So now that I have definitions for the length of AC and BC, I could actually work out AB. So AB actually equals our longer length, which is all this distance from A to C. So that length of AC, subtract this length BC, that will help me work out the length of AB. So ABC was from formula equation 1, which is 100 over tan 30. And BC was 100 over tan 50. Now, I could evaluate that in a calculator. If I wrote down the results individually, it'd be 173.21, take 119.18. The result of that is 54.03 meters. So the distance between A and B is 54.03 meters. That concludes our examination.